Hello everyone. In this video we're going to be solving a system of equations. I'd like to call this a polynomial system, but it's not polynomial as is because we have a rational expression. 1 over x plus 1 over y plus 1 over z equals 1. Anyways, we have this equations, we have this system of equations, and we're going to be solving for x, y, and z values. So, one of the questions you need to ask yourself when you're solving systems of equations is this a symmetric system? In other words, if I switch the x, y, z around, do I get the same answer? So that's going to be helpful, one of the things that you can do. Another thing you can do is think about the identities that you can use, such as a plus b squared, a plus b plus c squared, the cube of a sum, the sum of two cubes, sum of three cubes, so on and so forth. So all of those have different formulas that you can utilize. You just got to be familiar with them. Here's what we're going to do. First of all, the first equation gives me the sum of x, y, and z. That's nice. So this is the sum, and this is kind of like a, two-way product maybe, we can call it. But these two equations kind of remind me to use something that should be well known to you. And by the way, I made a video on that, which is Vieta's formulas. You can go ahead and check it out here if you're not familiar. But Vieta's formulas gives us relations between the roots and the coefficients. Okay? So for example, if you have a quadratic equation such as ax squared plus bx plus c equals 0, then x1 plus x2 is going to be negative b over a, so on and so forth. I don't want to get into the details. You can definitely go ahead and check out the video that I talked about on Vieta's formulas. Vieta is a French mathematician, by the way, so he did a lot of great things. You can definitely search for that too. Anyway, so I have these two. Why did I mark the first and the third? Because those come up in Vieta's formulas. The second one is the sum of the reciprocals. So what should we do? What do you think when you are given a sum of fractions? What do you think of? Aren't you thinking about making a common denominator? Obviously, you can also isolate one of the variables, plug it in, so on and so forth. There's so many ways to approach it. But let me just go ahead and go with the standard method first. So I'm going to make a common denominator. I'm going to get yz plus xz plus xy divided by xyz equals 1. Since it's 1, we can go ahead and cross multiply. And let's go ahead and write in standard form. Otherwise, this is going to bother me forever. xy plus xz plus yz equals xyz. So, what does this mean? We were given the left-hand side. Yay, this is equal to 27. So if two things are equal, and one of them is equal to something, the other one is also equal to the same thing. Anyway, so this means xyz is also 27. So that's kind of nice because we got the following. We have x plus y plus z equals 9. And then we have xy plus xz plus yz equals 27, right? And obviously, and we have what? xyz equals 27. These two are equal, but that's okay. This is a system of three equations, and we have three unknowns. So we got rid of the second equation real quick, and let's focus on this one. Now, this is significant because this basically gives us all the relations or relationships that we can get from Vieta's formulas for a cubic equation. In other words, if you know the sum of the roots, the product of the roots, and the two-way products, you can basically form the equation. So, suppose you have an equation whose roots are x, y, and z. And obviously, when you try and write the cubic, you can use x, y, or z. But it's better to use a generic variable that would represent all three. Something besides x, y, z. Makes sense? That's why I use a different variable. Don't get confused. Whatever variable I use will represent all of x, y, z. So let's use t, because t is fun. How about this? We're going to write this as t cubed. And then minus the sum is going to come, x plus y plus z, t squared. Plus the two ways, x, y, x, z, y, z is going to come here with the t, and minus x, y, z equals 0. So this is basically the equation, a cubic equation whose roots are x, y, and z. Okay, makes sense? So kind of like a formula. And since I know those values, I can just plug them in, and let's see what that gives us. So I'm going to go ahead and replace all of these here. X plus y plus z is equal to 9. So I'll be getting x cubed minus 9t squared. And remember, these were both 27. So it's going to be plus 27t minus 27 equals 0. Now, what does this look like? You can definitely use what is called the cubic formula. So let me briefly talk about the cubic formula, whatever you want to call it, by any name, but I'll call it cubic formula, and just briefly talk about it. So I want to get rid of the t squared first. To do that, you look at the coefficient of t squared and divide it by -3. Why by -3? Because there's always a negative in the formula, and you have to divide by the degree, sort of. So fourth power, you have to divide by -4. Okay? So I'm going to go ahead and take the -9, divide by -3, and then add it to another variable. So like, how about besides anything besides x, y, z I have to use, how about m? Okay? M plus this. That's what I need to do. And this needs to equal t. So in other words, I need to replace t with m plus 3, because that will get rid of the quadratic term. Let's check it out. M plus 3 cubed minus 9 times m plus 3 squared plus 27 times m plus 3 minus 27. Constant is obviously going to stay as constant. Let's cube this number. The way I cube it is usually cube the first and second term, and then I do a 3ab thing. That's going to be 9m. Remember, this is the formula we always use, times a plus b, which is m plus c. That's how I do it. You can do it differently if you want. That's totally fine. And then I get this, and then I get that, and I get that. So let's go ahead and put it all together. So I get m cubed plus 27 plus 9m squared. 9m squared. I don't know why this is acting weird. Sometimes it does. Plus 27m minus 9m squared minus 54m. I'm distributing the -9 now. Minus 81. And then plus 27m plus 81 minus 27. So this is going to be interesting. You'll be surprised with this, because 9m squared cancels out. 27m plus 27m is 54m. That cancels out. 81 and -81 cancels out. And -27 and 27 and -27 cancel out. And you end up with m cubed equals 0. Wow. That was really cool, wasn't it? Okay, you weren't expecting this, right? This is like the dream scenario with cubic formula. Obviously, this is not going to happen 99.99% of the time. So t equals m plus 3. So from here, m is 0. And t equals m plus 3. So t is equal to 3. So t is equal to 3 is good, because this means x is equal to 3. Y is equal to 3. Remember, we were... T represents x, y, and z, right? So all. But getting a single value from the cubic formula means that the roots are identical. They are equal, whatever you want to call that, triple root. So why did we get that? Why were we so lucky to get something like super duper nice? Let me tell you a little bit about that, and we'll finish up. Okay. So from here, we're basically getting a perfect cube. If you are familiar with the coefficient, you'll hopefully realize from binomial theorem that this is t minus 3 quantity cubed, which indicates t equals 3 is the only solution. Therefore, x, y, z all have to be 3. And if you look at the original system, you probably recognize this, because 3 plus 3 plus 3 is 9. If you add the two-way products, you're going to get 9 plus 9 plus 9. If you add the reciprocals, 1/3, 1/3, 1/3, you're going to get 1. And that's the only way to get this result. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.